So we'll look at the next two slides here. Draw a circle with center C, a radius, chord, diameter, secant, and tangent line. So just making sure you know your different definitions with respect to a circle. So it says draw a circle with center C. Draw a circle with center C, so I'll draw the circle. Here's my center. We'll name that C. And that doesn't really name, we don't have to name the rest of the things, so I'll draw a radius. A chord, so a radius, goes from the center just to any point on the circle. A chord is a segment that connects 2 points on the circle. Next we want a diameter. Let's change color for now. Diameter is a chord, it's just a special type of chord. It's a chord that has to go through the center of the circle. So there's that red one is a diameter. A secant, which is a secant line. A secant line is simply a line that intersects the circle at more than one point. We're going to have to cross through here, so this is a secant line. That's bad. Secant line. And lastly, a tangent line is a line that intersects the circle at just one point. Which hopefully I get this. Here we go. So yeah, there's our tangent line. And so it just intersects at that point. That's called the point of tangency, which is referred to in number 38. What is the relationship of a radius and a tangent line that intersect at the point of tangency? That's something we should actually just know. I'll sketch it out, but here we'll draw a tangent line. It's a little bit off. So let's draw another one so if I can do this better. There we go. So there's our tangent line, and we want a radius that intersects that. And what we notice here, what's the relationship? It is perpendicular. So the answer to that is perpendicular. Or you could write intersects at a right angle. And now number 39 uses something we learned about secants. We learned that about tangents. If a tangent comes from the same point and it hits the circle here, so there's a tangent that hits the circle there, here's a tangent that comes from the same point and hits there, these two segments have to be the same length. So since this first one was 8, this other one has to be 8. And so we can work our way around. Since this length here is 2, this has to be 2. And since this length here is 5, this one also has to be 5. And so now we can easily find the perimeter of that triangle by just adding up all of those sides. If you add those all up, you get 30. So the answer is this is 30. There's no label, so I'll just put units here. 30 units. Okay, coming to this next set of questions, these deal with angles in circles. So down here at the bottom, we're going to do a quick review of what angles equal when they're within or around a circle. So I split this up into 3 different parts. Angles formed inside the circle. We learned that if we have an angle that's inside the circle, the measure of the angle equals 1/2 the sum of the intercepted arc and the vertical angle's intercepted arc. And so we have this equation here, so we can plug in the equation. If we know 2 out of these 3 things, so if we know the measure of the angle and one of the arcs, we can find the other arc. But you just need to know 2 of them, and you can find the third one. If the angle's formed on the circle, we know the measure of the angle is simply equal to half times the intercepted arc, or half of the intercepted arc. So that's if the angle is right there on the circle. And then the last one, angles formed outside the circle. Here, I'm going to make sure I have enough room. We know the measure of an angle is 1/2 the difference. In this case, this angle will intercept 2 arcs, and you're just going to do the bigger arc minus the smaller arc. And we'll take a look at how to use these in these examples up here. So in this first one, we have an angle formed. We're looking for to find W. That angle is formed on the circle. So this first one, we're looking at this theorem right here. It's on the circle. So we know that that angle measured W is simply equal to half its intercepted arc. So we see here, here's the arc that it intercepts. It's just half of 98. And so W is 49 degrees. The middle one is, we have an angle that's formed outside the circle. So here we're looking outside the circle. So we're going to be looking at this formula here that's dealing with outside the circle. And we see, so we have it right here, the measure of the angle. Well, in this case, we actually know the measure of the angle. It's 22. So again, I'm just plugging into this. So measure of the angle is 22 equals 1/2 the bigger arc minus the smaller arc. So here's the bigger intercepted arc. That's the 100. And then we're going to subtract x. So that's our equation. Please show your work on these because you can get partial credit if you're doing your work and then just make a silly mistake doing the algebra. So you can do this a couple different ways. You can distribute the 1/2 to start with, or you can multiply by 2 to start with, which gets rid of the 1/2. I think we'll go ahead and distribute for right now. So we'll distribute the 1/2. We get 22 equals 1/2 times 100 is 50. And then 1/2 times x is just half x. We'll go ahead and subtract 50 from both sides. 22 minus 50 is negative 28 equals negative 1/2. And then we want to get rid of that negative 1/2, so we're going to multiply both sides by negative 2. And on our right side, we just get x, and on the left side, negative 2 times negative 28 is positive 56. In this one, there's also a y. Well, we just found this is 56. And so now to find y, we know that a full circle is 360 degrees. So we can take our 100, we got our 100 plus 56, which is obviously 156. We're going to subtract that from 360 degrees because the whole circle all the way around is 360 degrees. So when we subtract that, we get 204. So y is 204. And so we found those two parts there. And then our last example here, looking for a z, we see that we have two angles. We have an angle that's formed inside the triangle, inside the circle. So we're looking at this. We're looking at this over here. And it's inside the circle, so what we're going to do is we have the measure of the angle, which in this case we're looking for that, so z equals 1/2 the sum, so here's the angle we're looking for, of its intercepted arc. It's intercepting this arc right here, 93, plus its vertical angle's intercepted arc. So we have to look across. Here's our vertical angle, and here's its intercepted arc, which is that 17 degrees. And now we just have to evaluate this. 93 plus 17 is 110, and half of 110 is 55. So we see that z is 55. So make sure you know these different formulas. Angles formed inside the circle is half the sum of the intercepted arcs. Angles on the circle is just half the intercepted arc, and angles formed outside the circle is half the difference of the intercepted arc.